we're going to look at applying the power laws in the higher merit and excellence questions, which is using the same rules as we've always had, but in a different set of situations. Because at years 11 and 12, generally we know what the base is. As a variable, when we are asked to simplify a question like this, the x, the unknown, is the base, and all the powers are numerical terms. It doesn't have to be that way. We could ask to simplify a situation like this. Same rules apply, but the context is different. First up, we've known for a long time, you multiply two numbers of the same base, then we add the powers. So the base is staying the same, and we're adding power. But that's also true if the base is a number. So in this case, we've kept the base the same and add the powers, just like we always have. Division is the opposite. Instead of adding the powers, we subtract. So the 5 minus 2 is 3, but in this case, the bases are the same, so we subtract the powers. Second rule, if the power is the same, then we multiply the bases. That's a variant of this rule. 2 to the x, 5 to the x makes 2 times 5, 10 to the x. It's just applied in reverse. And again, division is the opposite. Provided the powers stay the same, we can divide the bases. So, power or base, one stays the same, we change the other. So, two rules and then a third principle. In order to use the first rule or the second rule, we may have to change the terms until we can use those rules. Let's see how that works in practice. We have to remember that if we have a power raised to a power, that we multiply the powers. It's particularly useful for changing bases because it means that we can take, for example, 25 to a power and rewrite it as base 5 to a power, and as 25 is 5 squared, we multiply the exponent by 2. And we also remember that when we multiply two bases, we add the powers, but we can apply it in reverse. So if I have a complex power, I can separate that into two separate multiplications. So let's take our two rules and our principle and see if we can apply them in practice. We look at this and we say to ourselves, can we raise them to the same power? Well, clearly we can't, because there's no way I can add a power of x to the 8. So I'm going to have to try and make them the same base, and to do that I recognise that both 4 and 8 are powers of 2. 8 is 2 cubed, 4 is 2 squared. So I can take my 4x times 8 and write it in terms of base 2. 4 is 2 squared, 8 is 2 cubed. Then I apply my multiplication rule for powers of powers. 2 to the 2x is 2 to the 2x, and then add the powers as usual. Key principle there is I recognise I can write them in the same base. Once I've done that, I can apply my rules. Here's another one. I'm never going to be able to apply these to the same base because 12 has a factor of 3 and I've got no factors of 3 on the bottom. So instead of changing them to the same base, I'm going to change them to the same power. I recognise that 2 to the 2x is 2 to the 2x, which is 4 to the x. At this point, I now have them in terms of the same power, and I can apply my rule and do my division. In this case, I look at it and I think I've got a power of x, I've got to a power of x, admittedly twice it, but that I know I can end up rewriting the bottom in terms of to the power of x. Here's 1. We look at it, can I write them to the same base or to the same power? In fact, I could do either, but I'm going to practice getting rid of this plus 2 so that I have them to the same power. In this case, plus 2 means times 4 to the 2. Now, I recognize that I've got 4 over x divided by 2 over x to the same power. 4 divided by 2 is 2, and 4 squared is 16. 16 is 2 to the 4, and I can rewrite it in power 2. Two rules which we're actually known for a long time, and then the principle that we try to use one of those two rules. Solving somewhat different. With solving, we have to apply the same rule that we would apply with standard linear solves. We get the unknowns to one side and numbers to others, and then we simplify those sides and solve what we have left. Some of these are quite hard, but I'll give you an example before we go. So we have a solve. We have to calculate the value of x, but I have x on both sides of that equation. I want it on only one side, so I've got to get rid of the plus 3. So my first step is to remove the plus 3. Now I have a term on one side, I can divide it over to the other side, and at this point I have my unknowns on one side of the equation and my numbers on the other. 4 to the x divided by 2 to the x is 2 to the x, and therefore x is equal to 3.